So this is what we get when we import the pre file that was exported from Turbo Design Pre. And in Turbo Design 1, as we see here, we follow a top-down approach in the tree. And so starting with the specifications, we can see all of these values have been pre-filled from TD Pre. So rotational speed, volume flow rate, etc. And this is actually the setup for the baseline case coming straight from the mainline code. So for example, the axial chord distribution we see here, the thickness, well, in this case it's a constant 2 mm thickness at the hub and shroud, but it's possible to specify more complex distributions. Then these two windows are showing the blade loading setup. So this first one is the span-wise work distribution, and just like we had specified the linear distribution, a linear variation from hub to shroud, and this is actually reflected here as well. And for the stream-wise distribution, blade loading, we have a forward loaded shroud and an aft loaded hub for this baseline fan. And once we have the setup ready, we just need to run to generate the first design. And once we have the design, which only takes 5 seconds or so, we have the 3D geometry, and then we also have the option to view the 2D plots of, for example, the surface relative velocity at the hub, midspan and shroud sections. And so let's rename this case to baseline. And then here, as we can see, we have quite a few performance parameters as well as geometry parameters. And in this case, it's possible to select a few of interest. So for example, diffusion ratio, profile loss and leakage loss are of interest in axial fans. And throat is something that controls the peak efficiency point. So we can select this as well. And then what we can do is we can only choose to view the parameters of interest, just like this. And then it's also possible to create 2D plot of any of these parameters which we want. So let's say we want to start with the profile loss. So now we can see the profile loss value has appeared in the 2D plot for this baseline case. So now for the first manual redesign, what we are going to do is we are going to make the blade loading distribution as forward loaded for both the hub and shroud, and we'll keep the same span-wise work distribution as the baseline case. And so all we need to do is then make the slope negative for both the hub and shroud. Something like this. So we can see now the entire distribution has become forward loaded from hub to shroud. And once this is done, we can click run again to get our first redesign. And then we can check the 3D geometry and the 2D plots again for the first redesign. And we can name this case as redesign 1. And then we can select the baseline case for comparison. So if we go to 3D plot first, we can actually combine the geometries and see the variation from the baseline and the current design. And also if we look at the 2D plots, it's very clear that because of that change in the stream-wise blade loading, what's happened is we can clearly see, since the hub has become forward loaded now, so we can see the loading on the hub has actually increased in the front side, and it's actually reduced at the rear portion. And also we can see in this 2D plot, the new profile loss value has appeared here for redesign 1, and there is actually a reduction in the profile loss, which means that we have a better design from the baseline already. So the next thing, for the next redesign, what we are going to do is we are going to introduce a leading edge loading at both the hub and shroud, like that. And what this actually means is we are actually imposing an incidence onto the leading edge. So zero loading means zero incidence, whereas a positive loading is actually giving a positive incidence to the blade. And we are still leaving the work distribution as the baseline. With this change, let us run the design again. And now we have our redesign 2, which we can rename like this. And we also see the 3D and the 2D plots again, and we can compare it with redesign 1, for example. We can see there are more changes to the design, as well as if we look at the 2D plots, the introduction of the leading edge incidence is now very clearly visible in these plots, which have opened up at the leading edge. And also, if we look at the profile loss, there is a further reduction compared to redesign 1. And in the final step of this manual redesign process, what we are going to do is we are going to leave the stream-wise blade loading as it is, but this time we are going to change the span-wise work distribution. So we have this linear variation in the baseline case, but what we are now going to do is change this distribution to parabolic. But we still need to maintain the mean RVT star as close to original as possible, because we need to maintain the blade work. So we can specify some values like this at the hub, mid-span and the shroud, and we can see that the mean RVT star value is still close to what we had in the beginning, but now the distribution has changed from linear to parabolic. And with this change, we can now run our final redesign. We can rename the case to redesign 3. And let's have a look at the post-processing plots again. And if we compare the design with redesign 2, we can see some further changes in the design, but not a lot of changes in the 2D plots, because we really didn't change the stream-wise loading. We only changed the span-wise work distribution. But then if we compare the geometry now with the baseline geometry, then we can see that how the redesign 3 is significantly different compared to the baseline geometry. And finally, if we look at the profile loss, we can see there is a further reduction compared to redesign 2. So with all of these redesign steps, we have basically improved the profile loss on the blade. And we can also choose to see other loss, other performance parameters on this blade. For example, we choose to see the diffusion ratio, which is an indicator of separation. We want to have it as low as possible, and we can see like eventually we have a much lower diffusion ratio than what we have in the baseline case. And the leakage loss, for example, is again much lower than the baseline case again. So with this, it appears that redesign 3 is quite a good candidate for CFD analysis, and as well as a target case for the automatic optimization in the next step.